Machine shop, we have a problem. Murray, what's happening, buddy? Hey, buddy, bear. Oh. Let's go. Lead the way, Murray. Lead the way. G'day guys, Matt from Hal Heavy Duty. We're the machine shop for a 60-year-old Aussie drilling company. In here, we fix all of the gear that drillers break and we make all the crazy custom components that these guys need to get the holes dug. Today's a bit of a different one. The largest part we've ever had to machine has just rocked up at the back door. What has happened is the guys over in Fab called me over a couple of days ago and said, hey, we have a problem. Now, to put this in context, the head of Fab, who's a friend of mine, I've known since I was 12, is one of the brightest guys I've ever met. So when he comes to me with a problem, I'm like, this is going to be good. So I go for a wander over there, and the drive head of our MEGADRILL has warped when they've welded the flange on. For those of you that are new to the channel, we are right in the thick of building a 3-meter MEGADRILL to drill underground mining and ventilation shafts, and we're going to send this thing 250 meters deep in the new year. It's well off scale for things that we've ever done here in this shop, and it's challenged us to pretty much the end of our capacity all year long. This has been no exception. So I go over and have a look at it, and it's pulled when they've welded by about 2 or 3 mil. We didn't expect that. It is a 70 mil thick or 2.5 inch thick flange that it actually had gussets, but it's pulled in the areas that it wasn't supported. 70 mil thick. Didn't expect that. So I have no idea how to do this at that stage. And the only thing I can say is, cool, we'll get it done, just leave it with me. Famous words, when you don't know what to do, leave it with me. Come over and had a bit of a think about it. So first thing is, can you throw it in a lathe? The answer is no. Like the Hulk looked at me and went, piss off, buddy. It's way too small for that. Thought, okay, is there a vertical borer or a horizontal borer? Nothing in town of that size or scale. And we really don't want to take it off site. So the only sensible thing that I can think of next, which is call Phil. Now, Phil is a tooling specialist that we have been going to for the last 40 years in here. This is the guy my granddad Hal would have actually gone to. Wonderful gentleman in his 70s, and this guy has a wealth of experience that makes what I've done look like a tiny shallow pool. So Phil, come have a look at this one. I've got one for you. Like Batman, Phil gets here. Takes one look at it. Do you want to do it the dodgy way or do you want to do it the proper way? Now, being an Aussie, tell me about this dodgy way of which you speak, which was basically getting a big barrel grinder. I said, no, we're not going to do that. That'll take forever. He said, cool, you need to get a flange facer. I'd never even heard of a flange facer, to be completely honest with you. Now, this channel, if you've been watching it for a while, you will know I'm not here trying to pretend to be the best machinist. I am not like the wealth of all information. I'm just a dude having a crack. Like, we get sent in all sorts of crazy parts, and if you're part of this channel, you kind of just get to see how we tackle it, the tools we build, the solutions we get. That's why I wanted to have this channel. And the cool bit is, in the comments, I often learn new stuff anyway, so a bit of a win-win. So today, we've had the flange facer turn up. Let's go take a look at what's in the box.
So this is a pneumatic flange facer by Marcem. It can do diameters of up to 1 meter or just over 3 feet, and it grabs on the internal bore of a flange. So you can get ones that grab on the external and face inwards. This is one that grabs on the internal to face outwards.
Now we have to set this thing on the flange and dial it in. So we've got it in there quite secure. It took a little bit of fiddling around to get it right, as in we haven't used one of these before, so it took about an hour or so to get it there, about another hour or so to get it correctly dialed in, and we can only dial it in off the 4 points of the corner. Because the thing had probably warped a little bit, we had to do our very best to try and make sure that this is dialed in off the 4 points where it's least likely to have buckled, which is where the gussets had been butted up against it, so it wouldn't have pulled there. We've got all of that in, and then we've got to set up the actual machine itself.
That is clock. Definitely clock.
Now that the machine has been dialed in to 0 based on the 4 corners, we're just going to touch the tool off the face to get us a 0 point before we set the first depth of cut. Now to do that, we simply wind it in. Most machinists use the simple piece of paper method, which is inserting a piece of paper between the tip of the carbide insert and the flange itself. The thickness of a piece of paper is 0.1 millimeters, so that will let us know when we are, and you simply slide the piece of paper back and forth. That is how we set a 0 point there. So we're going to do that, then wind back and come in. 0.3 is the depth of cut. Between 0.2 and 0.3 is what's recommended. So because it's not particularly, like it's not a super rigid setup, that's the manufacturer's recommended depth of cut is 0.2 to 0.3 millimeters. So that's what we're going to do. We're going to set the machine into forward. We're going to go in the slowest speed for both feed, and RPM is controlled by airflow. So we'll be facing outwards on speed 1, and then we'll see how this thing cuts. I'm choosing, of the inserts available, it came with 2 different nose radiuses. So I'll show you a little bit about why we chose to go with the smaller one to begin with, for those who aren't super familiar with machining, and we're going to see how it goes, because it's quite a challenging like flange to face, to be completely honest, because we have interrupted cuts from the O-ring grooves that you can see there, which are going to probably upset the carbide inserts, and then we also have all of the bolt holes. On top of that, it has issues where it's most likely been heat affected. We won't know till we've cut into it, so it could be quite challenging. Talking to the guys from Marcem, the best swarf coming off this is where it actually does come off in longer strings. It's not going to be like normal machining where you want it to chip off. So this is, as per recommendation of manufacturer, how it should look. So it's cutting up to now really nice. And you can already see how it has distorted. So this is cut number 3. And you can see there that each time we finish a cut, the distortion becomes visible based on how it has not fully machined out. So far so good, but we haven't hit the interruptions yet.
That's up.
You want to go down?
We're going to go down.
I just have to rotate a little bit. Yeah, that's it.
That's all right in there.
Yep. Alright, let's hit the go button. There we go again. So just heading over to the fab shop, they're now assembling the 2 stabilizers for the MEGADRILL. So the part that we are working on will bolt onto this, and each of those 3 components assembled will weigh, I am predicting 20 tons, and the diameter, it'll have 3 different sizes, but the one they're working on at the moment is the 2.7 meter, or a shade under 9 feet. It's huge. So the Flange crane is actually really struggling to lift this. Now it's a 20-ton Flange crane, but the 20 ton is only right up close, like the closest lifting point to the crane. So what we actually ended up having to do to move this giant sucker around is actually using the 2 wobbly cranes together, because they actually seem to lift it better than the big Flange. So it's a wild bit of gear. This has pushed everything in the yard that we've got to the absolute limits. God, you make some noise.
Safety step.
So I've just come back over to check out the flange, and they're having issues with inserts busting due to the interrupted cuts. Now, so what we're going to do here is index this one around. You can see where the nose is busted. We're going to turn it around, or index it, and just try slowing it down. That's my first port of call, because I really do want to use a sharp nose radius if possible, just to avoid vibration, particularly as we get wider out in the cuts. So just as we've gotten through the interrupted cuts, we've come to issue number 2, which is it appears there's a band of heat affected steel. That is because there are 10 passes of weld that have gone behind this, and it has affected the composition of the steel. So it's going to be very challenging to have that not want to break inserts. So you can see that's the weld that is exactly behind that corrugated area. So I'm going to give it a go with a larger nose radius just to see if the tip will hold up. That corrugation is very frustrating because once it starts, it's the devil to get out. So we're going to give this a go and see if we can get it out. So the 0.8 nose radius insert you can see here has also busted, and I've got to actually stay with this whilst it's machining, otherwise as soon as that bust starts to create corrugation. So I'm going to index this one across and have another go at it. If this fails, I have a backup plan that I didn't think we'd have to do, but sometimes you've got to go old school on things, but we'll have another go. I'll just quickly show you, for those that are interested in this sort of stuff, the difference between the two inserts. So one's an ISCAR insert, one is Kennametal. You've got a DCGT. Now all the D stands for is that it's a rhombic insert. So the first number there stands for the shape of the insert. The second is the relief angle. So C stands for it has a 7-degree relief angle. The third number just stands for the tolerance, which really isn't as important. It's just how tight tolerances are on manufacturing. And the fourth number there stands for what sort of a chip breaker it has. So they both have a positive single-sided chip breaker. The main difference between these two inserts is just the nose radius. So in millimeters, 0.4 to 0.8. Now you can have a look. They're both chipping on the end of it, and that's what a brand new one looks like. You know, very nice, shiny, all that jazz. I find these sort of things bloody interesting. Like I'm always, you know, zooming in to see what they look like. Fascinating little bits of gear, but this is what a brand new 0.8 nose radius, which you can see there, looks like, and then they just get smashed up. And as soon as the tip breaks off, it will not get under and cut properly, and because it's only a very light cut, it will vibrate, make noise, create corrugation, and just give a horrible finish. So because carbide inserts, they're tough, but they're also brittle by comparison, this is going to continue to be a problem. Now, out of the two different inserts, you would use the 0.8 typically as your roughing insert, and then the 0.4 would be your finishing insert. But the challenge we've got is the depth of cut is only 0.3. So in typical machining, you want your smallest cut, or as I have been taught, is that your smallest cut wants to be just slightly above your nose radius, so that it will chip and not vibrate. So if your nose radius is 0.4, your smallest cut would want to be 0.5. This is in metric. I don't speak imperial when it comes to all this stuff. I still speak feet and inches, but I struggle to go through the imperial side of it. So I'm sorry to American friends, you'll have to convert it. But what I'm finding doing this is because the cut is so small, as soon as we get hard areas or interrupted cuts, it's just wanting to break inserts. So my solution is pretty simple. We're going to go back to high-speed steel, because otherwise I'm going to be up for a lot of money in inserts, and it's just getting very frustrating. So we're going to make up a high-speed steel tool and then give this a run. And the good thing about high-speed steel is it's way more forgiving. Great for crappy cutting conditions. We've sharpened the tool steel in a fairly standard fashion, but we've kept the nose as sharp as possible because we're not going to be taking any heavy cuts. We're just going to try and take a nice, sharp, shallow cut to get rid of all of that corrugation, and also so that it won't vibrate as we get further out on the diameter as we are cutting that flange. So we'll see how this goes. We're going to use lots of roll with this, lots of cutting oil, just to keep the high-speed steel as sharp as possible for as long as possible, because we're going to be here for a while, hence the introduction of a drip tray. Let's see how this turns out. The high-speed steel is definitely a winner, and I've found that by slowing it right down over the heat affected area, it remains sharper for longer. It still does have the issue of once it does get dull, it will vibrate, but as long as we keep an eye on it and pull it up when it does, we're having really good results here. We have to keep lots of roll coal up to it, because as soon as it goes blunt, especially in those heat affected areas, we get the same problems as we did with carbide. So lots of roll coal over the heat affected areas, and we're just going to plug along and do this 0.2 mil at a time. So yeah, it's going to take ages. It's the best option that we have. If you have a faster way that you think we could have done this, by all means let me know, because if we ever have to do another one of these, I would like to know. But this worked really effectively. I'm very happy with this machine. The guys were really good to deal with, and all in all, the end result has actually turned out pretty darn good considering the conditions that we were given. So I'll show you how it all faces out, and then we'll have a look at the end result. We also had to recreate the internal groove here, which is actually an O-ring groove. So we've had to take out the inside there as well, using the exact same method as what we had done for the outer flange. And then we've put in a grooving tool here, which we've just welded a piece of steel onto. This worked really well. We had about 4 or 5 other things that we tried that did not work at all, but sometimes you've just got to keep persisting. Well, that's the end result. So the flange is completely true. We've got to do a little bit of cleanup on the inside there, but all of the measurements are correct for the O-ring groove and the depth of the recess there, which is excellent. We need to also remachine the O-ring grooves that you can see there, the 6 of them for the airway pipes. But all in all, really happy with how that's actually started to look. Not perfect. There's towards the outside, particularly after the interrupted cut of the bolt holes, there was just nothing we could do. Try we did, but eventually we went, that will do, we'll buff it out. So pretty happy with how that all turned out. A lot of roll coal, a lot of patience, and some jobs are character building. That was one of them.
Well, all in all, I'm pretty happy with how that turned out. We got the job done. Look, it was very frustrating, mostly because one of those cuts takes about 2 hours. So it took, I lost count, because what they decided they wanted to do was not just take out the inner part, but face the entire thing. So it took a long time. We learned a lot during that. The cutting conditions were too difficult for carbide, so we ended up reverting to high-speed steel, which cut really well, but we had to keep it very, very lubricated the whole time with Granddad's favourite roll coal. Job got done. They were so excited that it was finished, they came and stole it to go and fit the, they're fitting now the wings for the teeth, the actual PCD button, so they're getting fitted right now. We didn't even get a chance to do the O-ring grooves, but it'll come back here no doubt in the new year and we'll finish that off. So yeah, they came over and said, can we have it? I'm like, take it, get it away, I don't want to see it again. So it's over there being fitted. Guys, it is the 20th of December. I just wanted to say a huge thanks. This is our last actual work day for the year. For the next 2 weeks, Australia shuts down. I don't know what it's like in your country, but here, not much happens after the 20th. I had intended on getting out to site to see the MEGADRILL fully set up so that you guys can see the big rig and show you the specs. The day that I went to leave, summer storms hit, which tends to happen here in Australia. So they're on code red and they'll probably be drilling in the early new year. So I will be out to site. Yes, you will get to see the entire rig set up. You're going to get to see the pilot hole get dug. You're going to get to see the monstrous big auger go into the ground. And finally, once we've got this big bad boy finished, you're going to get to see that MEGADRILL go 1/4 kilometre deep. So don't forget to subscribe to the channel if that's something of interest to you. And if you enjoy these videos, please give them a like because it really helps our little channel grow. Next week, I'm going to be doing a Q&A for Boxing Day. So if you've got questions for me, I've kept a bunch of the best ones throughout the year, and we only started this channel 6 months ago. So I'm going to be addressing a whole bunch of the most commonly asked questions next week, and we've got something a little bit special for you, so make sure you tune in. It is the most Aussie thing you will ever see. Well, that's it from me. Guys, I appreciate you. Thanks so much for being a part of the channel this entire year. If you're new, drop in the comments where you're tuning in from. We've got people from the North Pole, every state in America, 40-something countries at this case, so I'd love to know where you're tuning in from. Well, that's it from me. I'll catch you in the comments, and I'll see you on the next one.